Hello, folks. Welcome to the November 2021 event for the Atlanta Kubernetes Meetup. I'm Alex. My co-organizer, Joe, is not here with me today. Unfortunately, he couldn't make it, so I will be flying solo, but I promise you we still have some good content for you here today. As always, we like to start off with a call for hiring in the community. If you have a role at your company that's Kubernetes or cloud native related technology, go ahead and throw it into the chat. And I will read those out after the news section. So make sure you include information about how to contact somebody if they're interested, things like a link to the listing, a job title and all that. I'll also post those in the show notes as well. So that'll be shared out for people watching the recording in the future. And with that, I will get to the news while we fill those out. Bear with me just a moment while I grab that. Everybody see HackMD? See my notes? Cool. All right, so in the 123 release cycle, the Alpha 4 release was just released. So we're kind of closing in on being ready to release here. The code freeze was actually implemented yesterday for 123. So I hope you got those last minute PRs in because it's too late to get them in now. You can see our relevant fix releases have come in. I've got a handful of interesting things here from the community news, and you can see the promotions as well. I won't read those out because they're all pretty small, generic pieces. Things of interest, horizontal pod autoscaler V2 is coming in. It's a lot of interesting stuff. I haven't gotten to sit down and read it all. I was just joking with Scott about this, but there's something like 300 comments on this thread. Yeah, there's 240 just hidden in the thread. So I apologize. I don't have all the pertinent details. If somebody wants to deep dive on this and come give a talk on all the cool things in HPA V2, reach out to me because I'd much rather have somebody else read that and tell me about it than read it myself. And community news, the 2021 steering committee results have come in. So four of the 7 positions were up for grabs this year. You can see who the winners were here: Chris Blecker, Stephen Augustus, Paris Pittman, Tim Pepper. No surprises there. Those are all names that you'll know if you've been in the community. Definitely good stewards. They're in for a 2-year term. So, we wish them well. It's good to see these results and people who've been working in the community being recognized. This was something I saw on Twitter, actually, super interesting. GCP has actually implemented Envoy proxy as the basis for their HTTP load balancers now. So their old load balancers are now legacy, and now these Envoy-based proxies are their actual primary load balancer mechanism. You can see it in the docs. They actually call out that it's based on Envoy. Help if I spell that right. Yeah. So you can see on all of their non-classic load balancers, they're now Envoy based. In the conversation here on Twitter where this was announced, Kelsey Hightower was talking to Anna about it, and she was calling out that they're bringing in or already have all of the cool Envoy bells and whistles, so your traffic splitting, request mirroring, et cetera, and MTLS is coming to their load balancers. So that's really cool. If you're using an Envoy based service mesh or anything like that, or using Envoy in your system, being able to use these load balancers off the shelf along with your existing Envoy infrastructure is really cool. Very awesome value proposition. Love seeing these projects being kind of expanded on and adopted more widely. SigNode is collecting feedback on the Docker shim deprecation. They basically want to get people's opinions on how it's going, whether you knew it, whether you're ready for it. So this will be in the show notes. Definitely go grab that, respond to it. I think probably a lot of the people here were aware of it and handled it fine, understood it, but I think there was a lot of, it's one of those things where they're almost doing a postmortem around the communication of it, because there was so much of a panic when people heard Dockers being deprecated in Kubernetes. It was definitely a big to-do for a little while where people figured out what was actually going on there. So I think they're trying to learn from those experiences and figure out maybe what they can do and how it's actually going. CFPs are open for KubeCon EU 2021 until December 17th, and that's in Valencia, Spain. I'm going to be trying to come up with a talk to give just because I want to go to Valencia, Spain. Yeah, and those are open until December 17th, like I said. Definitely would be cool to see some people from Atlanta getting talk there. So let me know if you send a CFP or a paper in. This is a cool CLI I saw. Kube lineage. So what this does, this is a great troubleshooting tool. So it's a CLI, and you can target objects in Kubernetes. So the example they have here is a cluster role. What it does is this is pulling in all objects of all API types in your cluster and building a graph of them. And then you can target them and see what their parents are and what their children are. And you can see this is super detailed. So this is going all the way from a cluster role to a cluster role binding to a service account, to the pods using that service account, to the service of that pod and the API service and endpoint slices for that pod. I mean, it's really tracking that graph all the way down. This is an awesome troubleshooting tool. If you're wondering what the heck is going wrong, trying to troubleshoot, I guess in this case it would be a permissions issue. Something is weird with, maybe your pod can't talk to the API server properly. This is a great way to envision all the way, up to your cluster role, that your pod is using, and all the way down too. I can see a lot of situations where this would be fantastic for troubleshooting. I thought this was a really cool tool. I wanted to call that out and show it to everybody. And then last but not least, Knative hit 1.0. So I'd love to see these milestones. Scott, our speaker here that you'll be hearing from in just a minute, has been a big contributor to the Knative project. So congratulations to him and all the other people working on Knative. That's a big milestone for people to hit. And that is it for the news. Let me jump over and see what we have for hiring announcements. Looks like we've got a couple here. So I'm reading these live. I don't have these prepared, so I apologize if I stumble through it a bit. So Shahara says DigitalOcean is hiring a senior engineer for their app platform team. He says he's happy to answer questions. Ask Levy, SLEVY at digitalocean.com. I'm sure Shahar will be around for the social time after the meetup as well, and would be happy to chat about it as well. There's a link there in the chat, which again will be posted in the show notes as well. Tony Parker with eHire, he says they have a few Kubernetes-centric 100 remote DevOps and SRE roles available with clients of theirs. He said feel free to reach out to him about it. And that's all we've got for hiring. So going from there, first off, I want to thank our sponsors. As always, SalesLoft provides the webinar for us, and all, in better times provides us space and beer and pizza and fun things like that for the meetup. We will hopefully be getting back to doing those in-person meetups early next year. Obviously, we'll communicate with the community as we think about doing that and hopefully get that going again. But again, thank you to SalesLoft for kind of being the lifeblood of this meetup and keeping us going. During the talk, you can put your questions into the Q&A feature on Zoom. If you look at the bottom bar, there should be Q&A. Just type your questions in there. And if they're time sensitive, I'll read them out to Scott. I'll pause them and read them out to him. Otherwise, just hold until the end. And he said he'll call for questions at the end of his talk as well. Again, make sure to stick around for after the meetup. We'll have a social, a little bit of social time where we'll allow everybody on camera and chat as well. And with that, I'm going to go ahead and hand over to my friend Scott Nichols. He's a co-founder at Chainguard. He's going to be explaining to us, like we're 5 years old, about SBOMs, container signing, and container verification. So go ahead and take it away, Scott.
Thank you, Alex. All right, let's see here. Gonna share all the screen. And then okay. So I was talking to Alex about what might be interesting, and I have this analogy that I'm going to run by you, and so just stick with me because it's going to get a little funny, maybe. I don't know. So I just started a security company. It's called Chainguard. Chainguard.dev if you're interested. .com. That's a different product. But part of what we want to do is raise awareness of what in the heck all this stuff is. So I'm going to be talking about SBOMs, container signing, and verification, and I'm going to try to bring us along a elaborate analogy. So bear with me. Here we go. So first, let's make some muffins. Sorry, that's not a muffin. Ooh, that's still not a muffin. Okay, we're gonna make some muffins, right? I love muffins. Muffins are great, and let's say I really love muffins. Oh wait, no. And so, how do you make a muffin? you take milk, eggs, flour, blueberries, and you make a muffin. Right? So you bake it, it's a muffin. So that recipe is pretty good, works out. I started making them and demand was through the roof. People loved my muffins. So what do? I decided to start a bakery. Oh, sorry. Demand was super high, super high. So I made a new company called Octo Muffins. We are a supply chain muffin company. So we provide muffins. We bake the muffins and we distribute them wholesale through coffee shops. Okay, going great. My business is rocking. People love my muffins. But turns out the FDA is like, whoa, hold up. Actually, there's this thing called the Food Safety Modernization Act, which essentially says you need to have detailed audit records for how you transport and store your food, record keeping and maintenance logs of all the equipment that process your food or touch ingredients, record keeping of the ingredients themselves, like where they came from, where you use them, and associating the input ingredients to the output products. Right. So I look back at my muffin recipe and it turns out that, well, just saying blueberries isn't enough for the FDA. They don't want to know blueberries. They want to know which blueberry. They want to know what farm produced my blueberry, which distributor did I get my blueberry from, what time periods did that blueberry get acquired in that chain. And so those kind of parameters tend to be called batches or lots or other distribution terms, but we'll call them batches and lots. Okay, so now we have, so like for the flour, for example, there's this flour supply chain where it starts the farm, it has some sort of geolocation, the date that it was harvested, right? The date that it was processed through the grinder or flour thingy. That device has a maintenance record, and all that data gets associated to a product key that gets stamped onto the bag and then distributed, and then I can write it down. And my muffin supply chain starts to look pretty complicated, where there's several farms, several machines, a bunch of audit logs and maintenance. And part of what the FDA says is that for every ingredient that I buy for my business, I need to take all of the information that I can get from the product and create my own ID internally so I can track what goes in and which muffins got produced from which individual bags, like the literal bag of flour. This bag of flour turned into these muffins exactly. Because, actually, sorry, screw me up. Can you see? Maybe I can shrink this. There we go. Because those muffins get distributed to coffee shops and hopefully happy customers, except it not always, right? And that's the point. We need to be able to take those unhappy customers and possibly through some very advanced correlation or the FDA agents using other research tricks with all those information checkpoints along the distribution path, they can go and find that one chicken or that one farm or that one distributor and find out that there's bad eggs there. That's actually making a bunch of people sick, one of which is my muffin company for a particular batch of a particular muffin to a particular coffee shop. Right? And the same works the other direction. So let's say maintenance guy Bob accidentally drops his glove into the flour grinder. At the end of the day, Bob's like, uh-oh, I'm kind of missing a glove. I think it was in this machine. And they can go back and figure out every bag of flour that got produced from that machine from the time that the maintenance record was. They can possibly recall all those bags of flour preemptively so that, puke face guy doesn't have to ingest a bunch of glove. Okay, so there are records at each major transaction to allow for tracing and audits. Okay, all right. So let's simplify this whole process, right? Like at the end of the day, there's some origin of stuff. There's some process that happens to it. And then there's some artifact that results in it, right? So you got a field, you've got harvesting and grinding, and then you've got flour. You've got another farm, some picking during some week, and then you've got blueberries. Well, our cloud native supply chain kind of looks similar, right? Like we make a product, we produce artifacts, and then those products have dependencies, and those dependencies have dependencies, and so on until we get to the entire chain of stuff that we depend on. But what happens when somewhere, like some dependency finds a vulnerability or a bug, or some dependencies build chain has a compromise that's injecting bad code that we don't really want? How do we tie that back to our product and know if we're vulnerable or not? So the answer, just like the food systems have to have a record and audit keeping, there's something called an SBOM, which is a secure bill of materials, or software bill of materials. And it basically records everything that went into that artifact. And the best way is from when you have source and the raw dependencies, right? Like nothing's optimized out. The process collects every version from every dependency and produces just a giant list of dependencies that went into a particular artifact at the dependency's particular versions. So now we have, right, in an ideal world, everything has an SBOM attached to it. And as I'm pulling data in, I can kind of collect those things up, and my product can be coupled with this SBOM, which is this list of every particular piece of software and dependency and version that actually went into that artifact. And so, you know, when I do find if a dependency reports a vulnerability or a bug or something dramatic or something like that, we can actually go and investigate through the SBOMs if we're affected or not. And that's the point here. It's there needs to be the metadata and the fingerprints along that production path to actually see, well, yes, we should update, or nope, we're fine. We're not using that version. All right, so we've investigated. We found out that yes, in fact, this package that was vulnerable, we have that version, so we should upgrade some dependencies in it. And it looks like it's a dependency of our dependency, which is, you know, we have to make sure that the dependency updates its dependencies and so on. So normal software stuff. Okay, how do you make these things? So there are two options. There's SPDX and Cyclone DX. And honestly, I'm just getting into this world and there seems to be some drama, but for now I'm gonna choose SPDX because that seems to be what the majority of the people that I listen to are using. There's this other version called Cyclone. Your mileage may vary. Okay, time for a demo. So, okay, let's see. I have a little Go application. It's very, very simple, but I can show you the Go mod here. I'm using a few libraries, and I directly depend on the Cloud Events SDK and Kelsey Hightower's excellent E and V config. I'm not going to show you the code yet. That's later. But what I am going to show you is how I can generate an SBOM. Oh, wait, I see a QA. Increase the font. That's not a question, but I can do that. Okay. Cool. Yeah. Okay, great. So let's make an SBOM. So I'm going to use this SPDX SBOM generator, and it is it does some analysis about what's in the local directory, and it's going to detect there's a Go mod file, and one of the languages that it supports is Go. using modules. So it is going to go in and analyze that and spit out an SBOM. Cool, it did it. And let's go look at it. And to be honest, it looks like a bunch of gobbledygook, but it's exactly what we're talking about, right? It's the Git versions and the SHAs and all the stuff of all the things that went into my artifact. Or, if you're not really meant to do this locally, but if I were doing this in a real build system, the build system, as it's producing the artifacts, it would generate the SBOM as part of that process, and it would tell me exactly what got built so that I can go back and maybe produce the exact same binary and know exactly which versions of which dependencies went into there. So for example, in the SDK here, it looks like it's giving me the package name, but it also gives me the exact package version. So I can actually pull that exact thing. And if I'm seeing problems in production, I can go and look at the real reference, not the bug fixed 2.6.2, because those jokers keep fixing stuff. Okay. So that's generating the SBOM, right? It's very simple. It's just another build step that has to happen in the build server. But there are tools that generate this for just about every language that you can think of. But there's a problem. Just because I told you what's in there doesn't mean that I'm going to trust that you know what you're talking about, right? So in my muffin business, I'm getting a lot of demand, not just for muffins, but they want organic muffins. And so how do I, as a business, produce organic muffins? Well, I have to use organic materials. And so I need to trust the supply chain. When I'm pulling my ingredients in, everything in my ingredient list needs to be USDA organic certified. And that certified is really important because I can transitively take their certifications and apply it to mine, maybe with some additional certifications about oils, or I don't know, I'm not a baker for real, but so USDA organic is a certification that comes from the USDA. So the USDA acts as this independent source for claiming certification and process management and stuff. So they become right. So when we sign an artifact, all the way to the end, we can say, actually, this artifact I'm going to produce, it came from this trusted authority, just like in the USDA organics, that USDA organic label came from this third-party trusted source that has a bunch of processes and recommendations and stuff. We can do that same thing through certificate authorities and stuff for software. Right? So we can sign our artifacts, and it lets people know that this actually is coming from something that's trusted. Okay, so why even bother signing and verifying? The reason you have to do this is I could give you an artifact and I could write an SBOM that looks beautiful, but it's not actually what went into the artifact. It's just the curated copy just for you. And that sucks, right? So signatures on artifacts mean that we can verify the signature, which means we can trust the SBOM and we can trust the artifact. Without the signature, we don't know if we can trust the artifact, and we don't know if we can trust the SBOM. Okay, so let me show you a very, very simple demo of producing a signature for a container. I'm going to use my notes a little bit. So first thing we need to do is we're going to generate the container for everything. So let's just clear this. And so I'm just going to co-publish the artifact. So if you, sorry, I hope there's a Q&A. What is co? What is the co data directory? The code data directory could contain this data, but it doesn't necessarily. What I should make clear is that signatures and SBOMs are part of a deployment strategy, not necessarily the artifact. You wouldn't want to fill up your artifact that you're shipping with all of this metadata. It's more of a side channel. So it also goes to registry, and I'll show you that in a second. So let's make the image. I'm going to build for a bunch of platforms because I have a M1 now, and that makes life a little complicated. Okay, so now we have this Octo image, and it's a multi-arch container image, which means that I don't need to worry about what it's going to. And I'm uploading it to the GitHub container registry. Okay, so there it is. So if I want to sign that, I can use a new tool called cosign. I'm going to take that Octo image, and I'm going to use the experimental keyless sign. And so what this is going to do is you'll see it ask me to do a little toAuth. So I'm going to log in with my Google account. And what it's really done is produced a temporary key from the root signer that is hosted by the Sigstore project, and it's signed my container. Then it's going to upload that signature to my container registry. And it also, what it's asking me right now is, do I want to add that to the transparency log, which is interesting because it's an additional way to verify that it was my identity that signed this container using the public key. So then if I give you this container and you look at the signature and then you validate it, you can confirm that it wasn't just somebody that signed it on the public, the keyless thing. It was actually me personally, because there's this audit log, which is cool. Okay, so now my container is signed, and you don't believe me? Yeah, okay, fine. We can crane list this. So wait, I have to cut off some stuff. Here we go. So I've done this a couple of times, but the one that we just produced is A297. So we should change. Hold on. I got the same container because let's just build again real quick. So I get some new signatures for you, so I'm not lying. It looks more menacing when it's on a 27-inch screen on 30 font. Okay, and then now we can go and crane list. So the signature that just got generated is BO. No, oh, sorry, not the signature, but this latest tag is what we just produced. And so now we have to sign it. So we're going to sign the image, log in again. We're going to upload that to the transparency log. And then we're going to take a look again. And so now there's a new signature, and that matches. Let's see. B09. So B09. So this is the signature we just produced. Cool. Okay. Like 5. But we still can't trust this, right? Like just producing a signature isn't enough. I could sign anybody's check, right? Like there has to be this other audit step where, as the consumer, I take a look at the artifact and I take a look at the signature and I ask the authority of who signed that thing. I get their public key and I do the same kind of verification step, and I get the same. If I get the same signature, then it means that the process that produced the artifact and the signature came from this same authority, and I can trust the signature, and therefore I can trust the artifact, and then I can trust the SBOM. Okay, so let me show you what that looks like. By cheating. So very simple. I'm going to use the key list again with cosign from, and this is from the SigSword project, if that wasn't clear. And so we're going to verify. And what this is actually going to do is kind of do what I just said. It's going to reach out. It's going to talk to the authority that is assigned to this signature. It's going to pull the signature. It's going to pull the SHA. It's going to do some calculations. And then it's going to give me this giant bundle of stuff. And there's a bunch of tools that you can use to view this stuff. But, you know, it basically is a bunch of crypto pieces. It's trying to make sure that you know, you can verify who this is, and at the end of the day, you know, like, look, it was me that signed it, and this verify call didn't know anything about me. It got all of that information from the signature itself. Okay. Oh, okay. So I'm going to do a bonus demo. So in my cluster, I have a couple things installed. One being I've installed Knative because I don't know how to Kubernetes without Knative anymore. And and of course, I have Sockeye running. And if you don't know what Sockeye is, it's a Cloud Events stream viewer. Actually, I'm going to make this way smaller and then pump it up. Way too big. That's, sorry, way too big. There we go. Okay, so elaborate demo. But first, we're going to reject some stuff. I've already installed something called Cosigned, which is a validation webhook. I've set it up to do only include signed containers into particular namespaces. So let's create that namespace now. So there's a new namespace called restricted. We're going to use a special label on the namespace that the cosigned webhook is going to look for. And basically what we've done is said this namespace, the webhook must validate any request to schedule a container in this namespace. And it must have a signature in the registry it came from, and I should be able to validate it. And it needs to come from something I understand. And it's going to be the keyless one. And now I'm going to do something really weird, but I'm going to create a demo image. So just 1 second. So if you look at this code, it's not magic. I just made a temp directory. I added a very simple Go program to a main.go, and using gomod init and a little Go program, I can then co-publish a container. And so it looks like it's unauthorized. So, oh, yeah. Okay, cool. Yeah, right. So I copied one too far. So I'm going to do that again. I'm going to kubectl create into the restricted namespace a job called demo with this demo image. And I get denied, not allowed. Now, we could take what we know and we could actually sign it. But we need the experimental. This won't be experimental once the rest of the pieces are signed. So experimental, I'm going to sign the container. And now that signature has been uploaded back to my container registry. Normally you wouldn't do this like as I'm doing it. I'm just doing a very, very simple demo. But for demonstration purposes, we'll deploy it again. And now it actually got rejected again because I don't know why actually. Maybe I didn't sign. It might not be signing the root cert. Hold on 1 second. Let's sign this again. I'm wondering if that SHA that I just signed is actually part of the internal manifest and not the root one that's multi-arch. So we'll try it again. Unauthorized. Oh, okay. Maybe I've got something misconfigured. I have a blog post that this totally works. Moving on. Let's try applying our other device, our other Octomuffin job. This should. Okay, something's going on with my cosine webhook. Okay, all right, fine, but so I'm getting rejected. I don't know what Curvo is at the moment. Let me just show you the demo because it's cute. Okay. Cool. So for your demonstration purposes, I made this ingredient list that gets attached to a batch from an inventory ID. And then eventually these batches get sent as a lot to some location. And so using the batch ID, I can actually come in here and search for I can filter by subject on this lot and only see these things. And I could further search by other inventory pieces, but it's kind of showing, each ingredient gets an inventory ID and a batch ID because it's part of the baking SBOM thingy. Not really an SBOM, but an SBOM sort of. But yeah, so there's sockeye filtering batches and whatnot. How do my presentation go? Here we go. I'll have to dig into why that the cosigned webhook didn't work. It was supposed to be a bonus, but okay. So the SBOM generator I used is Open SBOM Generator, SPDX SBOM Generator. I'll send a PDF of all this stuff. The signatures I'm using, the main project is called SigStore. You can go to there, sigstore.dev. The tool that I was using is called Cosign from SigStore. But if you want to go further, one of the things that's really interesting is, everyone has these build pipelines, and it'd be really nice. The first step would be for everyone to start producing SBOMs so that we can understand some of the stuff. But it turns out that even an SBOM isn't enough because, like I was trying to show, there's the source, and then there's some kind of process that happens. And it'd be nice to be able to capture the process too. And so there's a project that's getting spun up called Tecton Chains that uses Tecton as the builder, and it as another piece of metadata about this artifact, it'll actually tell you exactly all of the processes that happened for a particular container or whatever you're building. It'll take all the Tecton actions and tell you the version of the tools that was running or whatnot. And so that you can kind of trace back, was there a tooling injection or some other thing? And if you want to go even further, there's a new website called salsa.dev, and it kind of outlines the justification for a lot of this work and why you want to care about this stuff. and then it introduces salsa levels for kind of grading how your infrastructure is set up, right? So that's all I have, and I have some time for questions, and be easy on me because I actually don't know everything. So I'm gonna stop sharing. Bam.
Looks like you've got one sitting in the Q&A now, if you want to read it, or would you rather I read it out to you?
Hit me.
So Parth asks, can the image signing be checked by, I have no idea what this project is called, Kyverno, Kyverno, Kyverno. Can the image signing be checked by Kyverno also? And is this any different?
I don't know the answer to that because I don't know what that project is, but I can go look into it.
Fair enough. And then Carlos was commenting in the chat during your demo saying that he thinks, he thought it looked like you might have had the webhook misconfigured looking at the wrong container registry. It looked like it was calling arc.io and he thought maybe you were looking for GCR. I don't know if that's so much a question as it is a comment. But.
I'll send a blog post that I just wrote. I basically, that last piece of demo was this blog that I wrote a couple of weeks ago, turned into a very quick, tried to make it a bonus for us, but I think, yeah, something was misconfigured.
Fair enough. Any other questions, folks? You want to sneak them in now? Now's the time. Parth asks, was that a custom webhook or part of Cosign?
It's part of Cosigned. It's called Cosigned. They might be renaming it. It's still kind of in development, but it's part of the Cosign project. So Cosign itself is the CLI tool that you can write stuff. And then there's another piece called Cosigned, which is the webhook and Kubernetes piece that you can install, and it leverages the things that Cosign produces.
Let's see, Carlos asked, does the webhook need a secret to access the image registry?
Yeah, that could be. I created this registry about 3 hours ago, so I don't think I had it all the way set up, and it's kind. And yeah, so there's, sorry. When it's working, it's like, boop, nope, you cannot deploy that. And then when you do sign it, it can go and pull the secret, but I think that's absolutely what's going on.
Okay.
It's the signature is a private thing. I'm sorry.
Jacob asked, is in Toto a SBOM tool? In-Toto?
Yeah. Okay. So I believe in Toto is a way to provide attestations onto container metadata, and it's associated to the signing. So it works with in Toto, but it's not necessarily, it's not a replacement. All of this stuff that I just showed you in Toto is actually under the hood working with stuff. Okay,
great. Any other questions, folks? Looks like that's all that are on there right now. I'm not going to read that one in the recording.
Did you get the analogy? How did it go?
Yeah, absolutely. I think that's a great way to explain the idea of what the the kind of bill of goods is. I know it makes sense, right? As a way to trace everything through the supply chain back to suppliers, then back down again. I think that's a great analogy for it.
Awesome. Yeah, this stuff is like, it's really complicated, and it's the way the security space talks about this stuff, it doesn't tend to be kind of rooted in stuff that developers really think about. Yeah. And so I was trying to make it a little easier.
Yeah, I think that's the best marketing that the FDA has had in a long time. So I'm sure they appreciate you as well.
Thank you.
Carlos has a question here. I'm not sure if this is meant for you or if he's just commenting. It says Kubernetes and other open source projects are adopting to sign images to trust them, or is there no need to rebuild inside house? I'm not sure exactly what he's getting at there. I think he's saying that, is this something for wider projects, or is this something you use for internal images?
Yeah, I mean, so the industry does a bunch of things, right? Like a very small shop might not have the resources to rebuild every image that they produce. And if And the reason the big companies do this is because they can't necessarily trust some random image in some container in some registry, because there's no way to validate that who you are talking with to produce to pull that image is actually the entity that produced that image. And things like iPhones and Mac and Debian have done this for a long time, to some degree, where the packages get signed, and then there's a root authority and a bunch of certificates, and in Apple's case, you have to pay money to produce these things, and it's all trying to do the same thing. But I think we're seeing a migration to, we would like to be able to trust the things that are in the public registries too, because right now it's essentially like curling a bash script from the internet, except it might end up as root on your cluster, which is super scary, which is why big corporations go and they pulled all of their artifacts down and rebuild everything from source. I don't think that's scalable necessarily for every single business. And if I had a way to say, hey, Joe, sorry, hey, Alex, I have this container, I signed it, here's my signature, here's the two pieces, and now you can validate it and deploy it to your production with confidence that it actually is the artifact that I produced. And it's even better if it comes with the SBOM, because you can look inside and be like, I trust that you built this, but what is it? Now you can check it out.
Eldon asks, what is the default duration of the certificates?
The default duration from so that experimental piece, you're basically getting a certificate that lasts for 20 minutes. The root lasts for much longer than that, but there's an ephemeral in-memory key, which you saw me do the little two-legged thing. The key that comes back that's stored in memory for the duration of the cosign call is 20 minutes long. So if you manned in the middle of that, potentially you could steal it, but it's HTTPS, and then it's never stored to disk. So as soon as that program is done, the thinking is that it's gone.
I guess one of the other elements of that question was like, is there any concern about availability? If like you get a new node, it expects to be able to check a certain certificate or something gets redeployed. So I did a silly thing. I had kind of a toy cluster that was stood up with Typhoon. And of course, Typhoon creates you this root certificate, which expires after a year, which makes perfect sense because they expect for you to migrate your workload between Kubernetes versions. And no, you don't want to stay on the same Kubernetes version for a year. So anyway, this toy cluster basically totally shut down from an availability perspective because the root certificates had expired. And I guess just from a risk management perspective, is this another thing that you need to put on the calendar to check every 12 to 24 months?
Yes, unfortunately, yeah, the root cert will have some time period and it should be refreshed. The thinking though is that if you have the SBOM and all this information, if you go look at salsa levels too, you need to be able to you should be able to be have the ability to reproduce the same artifact with all the same inputs, and it should produce the same output. And then it's just a matter of re-signing that new output, validating that it is what you want. And to be honest, like the way the industry works right now is if you're not rotating your containers and libraries and all the stuff you depend on every, let's say 1 year max, you're probably vulnerable to something because there's so many packages in all of our pieces.
For sure. Yeah. No, I mean, it's legitimate it's totally legitimate from a security perspective, but like you also have to like consider the availability element of it, there are definitely entities out there that would prefer to run old software to risk, an availability event.
Right. And in that case, they would turn off the container signing because they're opting to be vulnerable to whatever, or they're opting to trust their containers. They know what they are.
Yeah.
So we had one more question. I'm going to rephrase this one. Jacob asks, how does cosign compare with notary?
They are different. It's a different strategy. So basically, cosign is betting on, if you know about Let's Encrypt, where possibly the reason why most websites today have HTTPS, that got popular because there's a public service that produces certificates for HTTP. It does the challenges and all that stuff for you. Cosign and the ecosystem that Sigstore is producing is making a similar bet that we can get container signing into the public domain by producing a public service. And I think it just got introduced to the Secure Software Foundation for Linux. So it just changes how the funding works for the project itself. But essentially, that's the main difference, is that they're trying to get the same result, except Notary is asking for major changes to a bunch of tooling and container registry systems, and Cosigned is saying, well, what if we just make do with what we have and make the world just one increment better?
It looks like that is all of our questions that have been posted so far. So thanks, Scott. That was great, man. That was really informative. And thanks for answering all the questions for us. That was a super informative conversation afterwards as well. And hopefully, Scott, you'll stick around for our social time after and can be barraged with more questions as well.
Great. Yeah, awesome. Thank you.
Thank you. Okay, folks. So now we will be moving on to our next presenter, which is me. So give me just a minute here to set up. Bear with me a second. Okay, should be seeing my slides now, and there's nobody else on video to tell me if you're not, so I'm going to assume you are. Okay, so what we are going to be talking about, thanks, Eldon, appreciate it, buddy. So what I'm going to be doing today is doing a quick introduction to Gatekeeper. So let's check this out. So Gatekeeper is Open Policy Agent for Kubernetes. That's our little subtitle here. So who am I? Alex Barnes. I am the organizer for this meetup you're attending at this very moment. I'm also an engineer at Datadog on their compute teams. That means I'm on the team building huge amounts of Kubernetes for Datadog. So what is OPA? OPA is not just a fun thing that Greek people say. It's also Open Policy Agent. Open Policy Agent describes itself as an open source general purpose policy engine. They say that you can use OPA to enforce policies in microservices, Kubernetes, CI/CD pipelines, API gateways, and more. So it's this kind of general purpose tool for writing and enforcing policies. Saying that something is, so what it is it's policy as code. And when I say policy as code, you're going to ask, okay, well, what's the code for that? They have a language that was created specifically for OPA called Rego or Rego. And they describe that as being purpose-built for expressing policies over complex hierarchical data structures. I'm not going to go too deep into what exactly OPA is and the details of it. If you want to learn more about it, go check out our October 2020 meetup, where Torin, the founder of the OPA project, actually came and spoke to us about it and did an introduction and kind of deep dive on OPA. He can explain what it is way better than I'll ever be able to. And that's not exactly what we're here to talk about today. So what are we here to talk about? We're here to talk about Gatekeeper. And what Gatekeeper is taking OPA, like I said, it's this general purpose policy engine tool, and it's turning it into a native Kubernetes tool. So adapting it specifically to use for Kubernetes. So it's got CRD based policies, which are still written in that Rego language I mentioned. It's implemented as an admission webhook, generally validating, but mutating is also coming. I think it's actually in alpha as of 3.6, and I think they've moved it up to beta as of 3.7, which I think just came out a day or two ago. All of the policies, like I said, are based are CRD based, and we'll look at those in a minute in the demo so we can deep dive on it a little bit. One of the cool things that Gatekeeper adds for you that's not really a generic feature of OPA is an ability to audit existing objects. So typically with OPA, you're passing it things, you're comparing it to your rules, and you're saying, hey, does this pass or does it fail? It also adds this audit functionality that will actually go back and look at existing objects for you as well, and tell you whether those are passing. And we'll take a look at that in the demo as well to get a little bit more detail. So the way Gatekeeper enforces its rules, or rather builds its rules, are through something called the OPA constraint framework. So OPA is, again, you program these rules in Rego, you put them together however you want. They add a little bit more structure to it for Gatekeeper, so that basically there's two main entities you care about. There's some other things, but the two things you really care about are constraints and constraint templates. So a constraint template, you can kind of think of like a function definition. You declare the inputs you expect, you write your code, and you return a value. They allow you to kind of reuse patterns easily, like a function would, based on different inputs. And then constraints, you can think of as a function call. And this will, again, it'll make more sense when we take a look at it. But a constraint is saying, take these rules that are written in this constraint template and apply it to some specific type of object or something like that, depending on how you declare your inputs. So you can kind of imagine that you want to enforce a given set of like labels being on all pods or something like that, right? Like you want to make sure that every team puts a label on their pod that says team and what their team name is. So a constraint template is the code that you would write that actually looks at pods and requires a label be there. Or rather, constraint template is, and then the constraint would be the declaration for the specific labels that you want. So you can say, imagine, require the input label on all pods, and then the constraint actually declares what that input label is. Again, this will make more sense when we take a look at it. So both of these concepts are represented as CRDs in Gatekeeper, and I say sort of there because there's an interesting mechanism they use around templating, and I'll show you how that's done. So again, I keep saying this will make more sense when we look at it in a demo. It's demo time. Let's take a look at this. Let's see how it actually works. Bear with me a second. Let me switch what I'm sharing here. Okay, should be seeing the terminal now. Okay, so let's take a look here. So the first thing I want to point out to you, I told you guys these things are implemented as CRDs. They're a little bit strange. Let's take a look at those CRDs. Excuse me. So right now, I've got Gatekeeper set up. I've got its components running. I'll show you. We've got this Gatekeeper namespace. There's this controller manager that's running. This is where our webhook runs. This is the thing that manages our CRDs. And then we've got the audit process as well. That's a separate process that runs for doing audits. These are the CRDs that kind of come with it out of the box. You'll notice here there's the constraint template I talked about. There's the constraints template status, and then there's these constraint pod statuses, but there's no constraint CRD. And I'll show you why that is. That'll make sense in a second. So let's take a look at these real quick. It'll make a little bit more sense if we start with the constraint template. So let's look at that.
Alex, before you move on, could you make that a little bit bigger for us?
Yes, absolutely. Let me fix that. How's that? Is that better?
Great. Yep.
Okay, great. Let me resize here so I'm not gonzo size on my terminal. Okay, great. So now we're looking at this constraint template object here. So what this one's doing is I want to require that all workloads in my Kubernetes cluster have requests and limits declared for resources, right? So that's what we're going to do here. Let's walk through the pieces of what this is doing. I won't go too deep, hopefully, but let's take a look at it. So these are the inputs right here that you're declaring. Remember how I said that these are kind of like function definitions and you can take inputs in? Your inputs are declared with OpenAPI, so your Swagger schema that everybody's used to. So what this is saying is that I expect something called resources. That's an array of strings. Pretty simple. This here, the CRD spec names kind, Kate's require resources, is actually declaring a CRD that's going to be generated based off of this template. And that sounds weird, but I'll show it to you and it'll make more sense if I just show it to you. Just keep in mind that's what's going to happen here. So then down here is the actual implementation of this. So you can see we have targets, Rego, and this is where our actual code is for the constraint template. So what these are, again, this is all written in Rego. These two functions, you can see it's strange. They're both named missing. They both take the same parameters and they both have the same return types. That's something you can do in Rego. If two functions have the same name and the same signature, they'll actually both be called whenever you call them. So this is just a convenient way of doing two checks with one function call, or with what looks like one function call. I'll jump back up to these in a minute when they're called, and you'll understand a little bit better what they're doing. So the way things are declared in this constraint framework version of Rego is you have these things you declare called violations. Okay, and then each statement inside of these needs to evaluate to true for it to continue on. So essentially what you can imagine is that every statement is implicitly anded with the other ones, with everyone before it. And if any evaluates to false, it just stops evaluating and doesn't return anything. So for something to be a violation, every statement in the violation statement must evaluate to true, rather in the violation. Yeah, I said statement over there, apologize. So talking about this a little bit, this looks a little funny, but this underscore here is how you iterate over values in Rego. So this is, say for Python, this is saying for container in input review object, blah, 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 blah. This input review object is what you can think of as the review object for webhooks. So it's the same thing. This is the value being sent in for the webhook. And then for that object, we're saying, look at spec template spec containers and iterate through the containers. And then for each of these, remember, we're saying it must evaluate to true. We're saying that it does not have container.resources. So then this is the message that will be returned if you fail to have resources. This is basically a clone of that, but instead it's saying container resources requests. And then this is saying container resources limits. So the way this is working is we're accumulating up and saying, okay, you have to have resources set. And if you do have resources set, great. You have to have requests within resources, and you have to have limits within resources. If we just said you have container.resources.request set, but never checked that container.resources is set, this would just evaluate to nil. That's not true, and this would never return. So we have to kind of build up the checks like that. And then this is where the actual meat of it is. This is where what we actually care about is happening. So this is saying, again, iterate through our containers. And then this is a nested loop. This is saying iterate through that input. Remember, resources is the name of our input parameter. So under input parameters resources, iterate through that array. And then for every container, call our missing function on the container's limits and say, does it have this resource? So what this resource is going to be is a string that says like CPU or memory, and it's calling missing on its limits. So jump back up here. You can see this makes a little bit more sense now, right? This is saying that the object, which is the resources.limits, doesn't have CPU. And if it does, return true, which means the violation gets posted. And this is saying that if it has it, but it's set to blank, return to true. So it's saying either if it doesn't have CPU requests at all, or it has CPU requests, but there's no value set, return true. That's what missing does. And again, if that evaluates to true, that's a violation. Then same thing here for requests. So this one checks limits, this one checks requests. That's our Rego. So pretty simple, straightforward checks saying, make sure you have request limits for whatever the input resources are. So let's quit out here. Oh, don't save those because I don't know what I accidentally put in there. So we're going to post this constraint template. Now, remember I told you how it generates a CRD? We can actually check that out now. So let's look back at kget CRDs, and you can see now, based on that spec, how I told you, again, let me show you that again real quick so you remember what I'm referring to, how it has this here, spec CRD, how it has spec CRD, spec name, kind, Kate's require resources. Again, that's declaring a CRD. So now that I've posted my template, that CRD exists now. That wasn't there earlier. Kate's require resources dot constraints dot gatekeeper. So that is declaring a special CRD based on this constraint template. So now I can create CRDs of that kind. And I have an example here. We can check out our constraint that's going to pair with this. Actually, let's open it in BI. So it looks a little bit better. So this is kind Kate's require resources. You can see that's a CRD, and that type was generated by the template. That's how they've implemented this in Gatekeeper. So the spec on a constraint, we've got a few choices on how we want to enforce this. I'll come back to this in a minute when we look at enforcement. But our options are dry run, warn, or deny, and they're what they sound like. Dry run means let it happen, don't worry about it. Just kind of test and see if this works. Warn means send a warning, and then deny means don't actually let the object through. You can choose to exclude namespaces. So a lot of people, you can assume, you exclude things like cube system, right? You don't want to disrupt the running of the cluster, or, whatever. So then these are the kind of objects here under kinds that actually get evaluated by this constraint. So again, remember in our rego, we're checking spec template, spec containers. We wouldn't want to check, say, a config map, right? Like that wouldn't make any sense. Config maps don't contain containers. So we need to tell it what we want to evaluate against. So in this case, we're going to evaluate against daemon sets, deployments, jobs, stateful sets. Those all share that spec template, spec containers format. So it can be evaluated with the same code. And then here's the parameters we want to pass in. Remember, we said we're passing resources, which is an array of strings. And these are the resource types we want to check. We want to check for memory and CPU. But we could, if we wanted to, hypothetically have a different a constraint for memory and a separate constraint for CPU or whatever. You can have more than one constraint for a given constraint template. Just like you can have more than one function call with different arguments for a function. Again, that's a good model to think of these with. So I'm going to go ahead and apply these. And you can see right now I've got this set to warn. I want to point that out. Okay, so we've got that. So now what I have here is I've got 3 deployments set up. Now imagine, I'm a developer. I've got this new application I want to post into the cluster. I'm ready to rock. Okay, I'm posting this deployment, and I just YOLO it into the cluster, and oh wait a minute, look, I got a warning back saying, my container, which happened to be named Nginx, is missing memory limits and memory requests. It's like, oh crap. So this is actually using the Kubernetes API warning functionality. This is a warning coming back from the Kubernetes API that is being generated by Gatekeeper based on those constraints that I have. So, all right, I'm a good developer. I don't want to be a bad guy. I want to kind of follow the rules and do what I'm supposed to do here. And actually, let me show you this. You can see it's true. I've got requests and limits on here, but I don't have, I don't have anything for memory. So, oh, I actually had these backwards. Let me jump to the other one. So if I add those, I add memory requests and limits. Actually, sorry. Here we go. Let's edit this. Let's try something. Oh boy. Let's say, just so I can show you and prove to you that what I said actually happens, where it checks for empties. Let's say I put it on there, but I'm not sure what I want, so I just try to post it partially. Oh, it won't actually let you do that. I have to have an empty string. Never mind, that's not going to work. Okay, but let's just say I remediate it, and boy, live demos. So I remediate it. I've added my memory. It lets me post it. Okay, so that's what warn looks like. That's using the Kubernetes API functionality to send warnings back. And let me show you real quick with dry run how this works. So we remember that this one doesn't work. Or with post warning, with dry run, nothing happens. It just doesn't complain. Audits will catch it, it'll report it, but the actual end user doesn't see anything as far as violation in the webhook. So now let's look at deny. And if I try to post my bad deployment, I'm going to remember it eventually. Oh, I didn't apply the constraint, did I? Deny. Unchanged. That should not work. That should be denied. Oh, interesting. So it's letting me update it. That's a misconfiguration. It works on updates. I've got something misconfigured where it's only checking on the initial posting and it's letting me do an update. So this is what it should do. So you can see it's the same denial, but this time it's not a warning. It's actually not letting me post it at all. This is completely denying the ability to post the object. So so you've got flexibility with those enforcement policies on how you want to go about enforcing these rules. You can warn people and kind of be gentle about it, or you can just audit, or you can fail it outright. So I've mentioned audit a couple of times. Let's take a look at that really quick. So like I said earlier, there's a separate process for auditing here. I've got something I have existing already to show you guys. So this is a deployment here called audit deployment running in the namespace enforcement. It's the same thing, except it doesn't have memory defined. So you can kind of imagine you've created a new rule, but it's not going to enforce retroactively, right? You already have objects in your clusters. People may not have followed the whatever rule you're trying to enforce previously. How do you find out what objects exist out there that aren't compliant with your new rules? That's where auditing can be useful. So this audit deployment I have here is just another random Nginx deployment, doesn't have memory requests and limits specified. How do we catch that? So there's a few ways you can look at audits. So the actual constraint object itself has status information for violations. So I'm looking at that constraint we were looking at earlier for resources, requests, and limits, and you can see under status violations, it actually knows that it should be that it would deny this audit deployment in the enforcement namespace that I just showed you, and because it's missing both memory limits and memory requests. So that this would, for every object in the cluster that's in an enforced namespace, you would have a violations object here for it every time the audit ran, and it's only the last run. They don't accumulate because you'd end up with infinitely growing list of objects here. You can also look at it in the logs of the pod. So every time an audit runs, you get these violation audited entries. So this is just, I'm just grabbing the actual audit pod and looking at its logs, and I'm grepping for these violation audited messages and just dumping those into JQ. And you can see these are all the violations in the logs. Again, for that same audit deployment and the enforcement namespace, it's a deployment, gives you information about it, how it would have failed. Obviously, you wouldn't really do this on the command line. You'd be using whatever your log aggregation tool of choice is, but it's structured such that you can easily report on these things. There's also Prometheus metrics built into it. So you can take a look here. I'm just port forwarding off to the audit pod. And then these are only aggregate information, but I can just curl again. I'm just looking at port forwarded to that pod. I'm looking at the /metrics endpoint on the audit pod. I'm looking at Gatekeeper violations, and it tells me aggregate number of violations for each type. So it would be doing 2 denials. Again, you saw those in the statuses of the object. So again, you can use whatever, you can use Prometheus or whatever metrics exporter you like to use to scrape these metrics and report on violations too. So you've got this nice reporting mechanism built in that is not native to OPA. This is something that Gatekeeper kind of gives you as a bonus, and is really nice when it comes to this kind of policy enforcement. Yeah, and so that's all I've got. It's a really great tool. It's a cool way to get to use OPA on Kubernetes. It's a much simpler interface. It kind of gives you that Kubernetes native interface of CRDs. I'm actually using this for Datadog. It's been a great experience, great community around it, really helpful people, and a really powerful tool. If anybody's got any questions, I'm happy to answer them. I don't see anything in Q&A right now.
Hey, Alex.
Yeah.
Apparently, since I'm a panelist, I can't put questions in Q&A. I wonder what your thoughts are doing this in the cluster with admission hooks versus doing it in your CI/CD pipeline.
Yeah, so it's interesting you asked that. So there's a tool called Comp Test that is exactly for doing this in your CI/CD pipeline, where you'd store these Rego rules and run them against objects to validate. So that's awesome. That is a very useful pattern, one that's well established with OPA. The thing that Gatekeeper gives you is more around auditing and like making a guarantee of what's actually running in the cluster. So you can imagine an auditor comes in and they want to say, prove to me that X. You could say, oh well, in CI/CD you can't do that, but there's ways to get into a cluster other than CI/CD. With Gatekeeper, you can actually guarantee and say this is what is happening in the actual cluster. So it's build time versus runtime thing. I'm actually looking at ways to try to generically enforce the same Rego between CI/CD and runtime without having to reproduce the Rego. Gatekeeper has a tool they're working on called the Gator CLI that lets you take the constraint template. Yeah, Gator, like you get it. That lets you use the constraint templates and constraint objects and compare them to objects without a running Kubernetes cluster as a way to validate them. And I'm looking at that as exactly a way to reuse these same objects in the CLI. That was just released in alpha, I believe, with the 3.7 release of Gatekeeper, which was like 2 days ago. Let's see, Grant asks, have you looked at ASA or OSA? I think it's a competitor to OPA, but integrate at the application level too and has different trade-offs. I have not, I'll have to check that out. I'm not familiar with that one at all. I'll have to check that one out. Oh, cool. Yeah, he posted a comparison as well in the links. You should post that into the chat as well, Grant, so it'll be persistent. Cool. Any other questions? Oh, Carlos asked, does Gatekeeper have cosign integration? I don't know. I don't think so. Great question. Maybe Scott knows that one. I don't.
You know what? We'd love to add it.
Carlos says he must be drunk with all the typos. Man, I don't know if you watched that live demo, but if you're struggling with typos, I must be real blitzed. Any other questions, folks? So yeah, it's a cool project. It really is. It's a great way to kind of let people use OPA off the shelf. OPA can be a lot to try to implement and figure out where to put it into your system. Gatekeeper makes it super easy to consume and to apply it to your Kubernetes workloads. I'm a big fan of the project. Cool. With that, that ends. That's the end of our formal itinerary. So thanks Scott for coming and speaking with us. Thanks everybody for coming out. As always, we're always looking for speakers. If you're interested in speaking, definitely reach out either through Twitter, through meetup.com, email us, katesatl@gmail.com. Hit us up on GitHub. We're easy to find. We're always looking for people to come talk. If there's interesting topics you've heard about that you'd like to have somebody talk about, definitely let us know as well. We can try to round somebody up. We're always looking to please. We will probably not have a meetup for December just because the holidays tend to be a tough month for meetups. It's hard to get people to talk, hard to organize things. We may do a social meetup. We're not certain, so stay tuned for that. And otherwise, we will see you in the new year. Hope everybody enjoys the holiday season and has a great New Year's. Thanks for coming out, everybody.